So in this video, I'm going to show you how to determine the heat that is involved when we're not only changing states of matter now, but when we're actually changing the temperature. So I can go from an ice at 0 degrees Celsius to a gas at 105, and I can figure out how much heat was required for that to occur. And so what I'm going to do right now, so I'm going to draw my heating curve. Okay. Draw it like this. And for each problem, guys, for these types of problems, you need to include a heating curve. And so I'm going to quickly write in, so this is a solid, that's a solid at a higher temperature, it becomes a liquid through melting, then a liquid at higher temperature, then a gas through vaporization, and then a gas at higher temperature. So remember, temperature is your y-axis here, alright? And just as a really quick review, if I'm moving from left to right, that means that I'm putting energy into the system. And so the process is going to be endothermic. Okay. If I'm going from right to left, that means that heat is being released, so this is going to be exothermic. And the reason why this matters, if I am moving from left to right, then the heat that's involved it's always going to be positive. While if I'm going from right to left, it's going to be negative. Alright? And that makes sense because if I'm decreasing temperature here, then my change in temperature is going to be negative. If I'm going from a gas to a liquid, heat is going to be released. So all of those heat values you calculate will be negative if you're going from right to left. So let's look at an example problem. It tells me that I have 25 grams of ice at 0 degrees Celsius. So I'm right here. And then it wants to know how much heat is required to make it a liquid here at 25 degrees Celsius. So my first step is going from a solid to a liquid. That's going to be step 1. So I'm going to go from a solid at 0 degrees Celsius to a liquid at 0 degrees Celsius. Okay, so that's step 1. Step 2, which I'll put down here, I'm then going to go from a liquid at 0 to a liquid at 25. Okay, so for this first problem, what you should recognize for step 1, I'm changing the state of matter. Okay, I'm going from a solid to a liquid, and so what I need to use for that is my heat of fusion. Now, if I'm going from a solid to a liquid or a liquid to a solid, I'm going to use my heat of fusion. Remember, solid to a liquid is positive heat of fusion, liquid to a solid would be negative. If I'm going from a liquid to a gas up here, I'm going to be using my heat of vaporization. Then if I'm going from a gas to a liquid, it would be in the negative heat of vaporization. But here I'm going from a solid to a liquid, so I'm going to use my heat of fusion. Well, I'm given that I have 25 grams of my sample. And the other piece of information that I know is that my heat of fusion is 6.02 kilojoules per mole. Well, I need to get my grams into moles in order to use this conversion. So I'm going to convert. I'm going to get moles on top, and I'm going to put my molar mass on the bottom. That's the molar mass of water. Okay, now I'm in moles. Now I can get into kilojoules by putting my kilojoules up top and 1 mole on bottom, and then the last step is to get into joules. So that's going to be 1,000 joules on top and 1 kilojoule on bottom. And so when I calculate that, what I get is 8,350 joules, because I want 3 sig figs. Okay? So that was for my state of matter change. Now I'm going to be changing temperature. So for changing temperature, you're going to use Q equals M delta T SH. Okay? Now, my Q is my heat, so that's what I'm solving for. My mass is 25 grams again. Notice here I'm going from 0 to 25. So my change in temperature is 25 degrees Celsius, and it's positive because I'm increasing temperature. And then I'm dealing with a liquid, so I'm going to put the specific heat of liquid water. Keep in mind, if it's a solid that's changing temperature, you need to put the specific heat of the solid. And so what I get for this is 2,620 joules. Okay? And so to find the total energy, the energy needed to go from a solid to a liquid, which is step 1, then from a liquid at 0 to a liquid at 25, which is step 2, I simply need to take these two values and I need to add them together. And so what I end up getting for my final answer here, when I add 8,000 and 2,000, is I get 10,970. Okay? So that's my final answer. So I'm going to add 8,350 plus 2,620. Okay? If you put just two sig figs here, that's totally fine, but I didn't. 970, and my answer is in joules, and that's my answer, and that's all there is to it.